This here is our experiment on conductivity. There are certain compounds that when we put them into solution are going to ionize or dissociate. So we're going to use a little conductivity meter to tell us whether a solution is conductive or not. So this is our little probe for testing conductivity. One thing to always make sure you do is turn the thing on. And we also want to make sure that the battery is good, so we're going to test this with something metal. Here we go. Okay, so the things that we're going to be testing include tap water, deionized water, straight from the DI water bottle. We also have sodium hydroxide, sodium chloride, hydrochloric acid, acetic acid, which is often abbreviated ACOH, ethanol, also abbreviated ETOH, but for different reasons. And then we have ammonia, NH3, not NH4+, that's a different species. We also have some sodium chloride that is in the solid phase, not dissolved in water. Okay, so what we'll do is we'll fill up a little tray to get a small sample of each solution. And when we do this, we'll get enough to test and see if they actually get a positive result. So let's do that. Okay, so we've added all of the solutions to our well plate. Now we're going to test the conductivity using our conductivity meter. Again, make sure that it's on for when you're about to test. We're testing the deionized water first, and since it's deionized, we should see no light coming on. Now, in between each of our tests, we're going to rinse off our conductivity meter with a little bit of DI water to make sure that we're not cross-contaminating our samples. The next thing we're going to test is the tap water. That's the water that you get from the faucet. Notice the difference. DI water and tap water are not the same thing. This is why you need to make sure that when you refill those DI water bottles, you fill them from the right tap. Next, we're going to look at some aqueous sodium chloride. Here we go. Note the intensity of the light when you see it. Okay. Next, we test the sodium hydroxide. Again, note the intensity. This can make the difference between a strong and a weak electrolyte or a non-electrolyte. Next up, ethanol. As we continue, we get to hydrochloric acid. And then acetic acid. Then ammonia. Now, one other thing we want to show is sodium chloride in the solid phase. So in this well plate, we have just solid sodium chloride. Notice that when we put our probe in here, we get nada. But what would happen if we were to add just a little bit of DI water? So this shows us the importance of having a solvent. These electrolyte solutions are mixtures. Without our solvent, we don't have a conductive medium. All right, those of you in 1411, we have something a little extra special for you. We're going to take a look at what happens when we mix ammonia and acetic acid and see what sort of conductivity we get there. Remember, these are considered weak acid and weak base. So ammonia is a weak base, acetic acid is considered to be a weak acid. So we're going to add a little bit of acid, and we're going to see what we get. Again, making sure that our probe is on, and put this into our solution. Note the intensity of the light. Now for comparison, I'm going to put this back into the ammonia and the acetic acid, the original solutions, before they were mixed. So the acetic acid, and the ammonia versus the mixture of the two. So we'll just put that directly in since it's already a mix. Okay.